Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n plus 6 factorial over n plus 2 factorial equals to 1680, and we will solve this problem for the values of n. So here you remember one thing is that our n is greater or equals to minus 2. We solve this problem for the values of n, and here we use the recursive method in order to find the values of n. So you know that about recursive method, if we have n factorial, it is equals to n times of n minus 1 factorial, and we again break this n minus 1 factorial and you write it as n times of n minus 1 n minus 2 factorial and up to so on. Similarly, you will just break this factorial sign and you get the more terms here. So now we here we use this recursive method and we can break the factorial of n plus 6 and you will get its output in this form. So now we break n plus 6 factorial up to the term of n plus 2 factorial. So here first you write this as n plus 6 and we decrease 1 and you get n plus 5, and we decrease 1 from n plus 5 and you get n plus 4, and we decrease 1 here and you get n plus 3, and we again decrease 1 and you get n plus 2 factorial. So I can just open n plus 6 factorial up to the term of n plus 2 factorial, and in the denominator we have n plus 2 factorial. So in the next step you will so this whole equation equals to 1680. So in the next step you will see here n plus 2 factorial, this n plus 2 factorial is cancelled out by this n plus 2 factorial, and we will get the terms here n plus 6 times of n plus 5 times of n plus 4 times of n plus 3 equals to 1680. And in the next step we will use here the nice important fact, and you know about this fact. So here in according to this fact we will first rearrange all these factors in this way. If you add these exponents of any two factors, so it will becomes the same answer. So here you see that if we add 6, if you add this 6 plus 9, you will get here 6 plus 3, you will get here 9, and when you add 5 plus 4, you will again get here 9. So now we can arrange this n plus 6 factor by n plus 2 and n plus 5 by n plus 4. So according to this rule we will rearrange all these factors and you get here n plus 6 times of n plus 3 and into you have n plus 5 times of n plus 4, and this whole equation equals to 1680. So in the next step you will just multiply these two factors and you will get its output in this form. So when we multiply these two factors here, then you get here n squared plus 3n plus 6n plus 18, and similarly when we multiply these two factors here, then you obtain n squared plus 4n plus 5n plus 20, and this whole equals to 1680. So in the next step we need to simplify the terms, and you see that we have the like terms on both of the factors. So you get here n squared plus 3n plus 6n equals to 9n plus 18, and in this factor you have n squared plus 4n plus 5n equals to 9n plus 20, and this whole equals to 1680. So in the next step you will see here we have n square plus 9n be the common factor, so that we need to make little bit simplifications here, so that here I can rewrite this expression as n squared plus 9n. We write this 18 as 19 minus 1. So you know that 19 minus 1 will be equals to 18, and here we write this expression as n squared plus 9n plus we write this 20 as 19 plus 1, and this whole equals to 1680. So here you see that we have n square plus 9n plus 19 be the common term on both of the factors. So here we just take this term equals to y. So when you take y equals to n squared plus 9n plus 19, then our above expression or above factors will becomes in the form of. So when you put this value in these factors, then you obtain here y minus 1 times of y plus 1 equals to 1680. So in the next step we will just solve these two factors here. So in the left hand side you have y minus 1 times of y plus 1, it is equals to y squared minus 1, and in the right hand side we have 1680. So here we move this minus 1 to the right hand side, then you get here y squared equals to 1681. So in order to find the value of n, here we need to take the square root on both of the sides. So when you take the square root on both of the sides, so our left hand side have these two and square root are gone, and we get y equals to plus minus, you know that the square root of 1681 equals to 41. So here we have again two cases here. So first case is we write y equals to positive 41, and the second case is we write y equals to negative 41. And now we can put the back substitution of y, and here you see that we take our y equals to n squared plus 9n plus 19. So now we back substitute this value here, and you will solve these two equations. So we put the value of y, and you get n squared plus 9n plus 19 equals to 41, and similarly when you put here, then you get n squared plus 9n plus 19 equals to negative 41. So now we can solve these two equations here. So now first we move this 41 in the left hand side, and you get here n squared plus 9n and plus 19 minus 41 equals to, sorry, I can write here 19 minus 41 equals to 0, and similarly in this case you have n squared plus 9n plus 19 plus 41 equals to 0. So now we can solve these two equations here, and in the first part you have n squared plus 9n, and you have 19 minus 41 equals to minus 22 equals to 0. So in this case you have n squared plus 9n plus 60 equals to 0. So now you remember one thing is that we need to solve this problem for the real roots only. So now first I can check is this equation has real roots or not by using the discriminant formula. So according to discriminant formula, first we write the coefficients of this term. We have a equals to 1, b equals to 9, and c equals to 60, and our discriminant will be looks like in this form: delta equals to b squared minus 4 times of ac. So we put the values of a, b, c here. So the value of b is 9, and the 9 square is 81 minus 4 times of a is 1 and c is 60. So you have 81 minus 240. So you clearly see that it will be less than 0. So if our delta is less than 0, so it means that it has no real root, no real root, so that we will just rejected this case. And now we can just proceed here this case only, and now we can find or make the factors of this equation. So in order to make the factors of this equation, we have n squared. We write this 9n as 11n minus 2n minus 22 equals to 0. So here we take common n and you get n plus 11, and we take common minus 2 and you get n plus 11 equals to 0, and we get here n plus 11 times of n minus 2 equals to 0. So we have the two roots of this equation. The first is n equals to minus 11 and the second root is n equals to 2. So this is the our final answer of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.